Welcome to The Explainer. I am absolutely thrilled to have you here today. Get ready because we're about to go on a mind-bending journey of truly epic proportions. Today, we're doing a cosmic zoom out to unveil some of the universe's most massive hidden giants. We're talking about structures so unimaginably huge that they're literally pulling our entire galaxy through space right now. So if you love discovering just how vast and mysterious our cosmic neighborhood really is, you are in the exact right place. Okay, let's dive into this apparent cosmic contradiction. We hear all the time that the universe is structured in these incredible, vast filaments of galaxies, right? And that because of cosmic expansion, they're constantly being pulled apart. Everything is moving away from everything else, and giant empty voids are forming in the gaps. But if everything is just drifting apart into an ever-expanding void, why in the world are we currently on a collision course with our galactic neighbors? Section 1. Gravity versus cosmic expansion. To solve this mystery, we really have to look at the grandest battle in the cosmos. In one corner, we have cosmic expansion, pushing everything apart, stretching space-time itself and creating massive empty voids. But in the other corner, playing the ultimate antagonist, is gravity. Gravity pulls dense regions back together. And that right there is exactly why the rule that everything is moving away from everything isn't entirely true. Technically speaking, gravity is the curvature of space-time, which is dictated by how mass is distributed. Now, on a local, stellar scale, gravity is what governs planetary orbits or, our solar system's trek around Sagittarius A star. But its true dominance is really revealed on the macro scale. When mass concentrations are high enough, gravity doesn't just hold individual galaxies together, it literally orchestrates the movement of entire galactic clusters. Section 2. Our hidden galactic collisions. When we zoom out to our larger galactic neighborhood, we see exactly what happens when gravity completely overpowers cosmic expansion. You've probably heard that the Andromeda Galaxy is hurtling directly towards us, right? Well, this happens because over localized regions, an immense gravitational pull easily outpaces the expansion of the universe. Gravity keeps our local Galaxy Supercluster bound tightly together, which makes slow-motion galactic collisions an inevitable part of our cosmic history. And this brilliantly illustrates our own galaxy's incredibly violent history. Scientists actually found ripples in the Milky Way that were consistent with a massive past collision. But the culprit? It was a total ghost. We were completely blind to it until the Gaia Space Observatory discovered Andromeda 2. This is a diffuse galaxy roughly the size of the Large Magellanic Cloud, and it was hiding right behind our own galactic disk. It was perfectly camouflaged. This is actually our first encounter today with the incredibly frustrating reality of what astronomers call the zone of avoidance. Section 3. Meeting the Great Attractor. And this brings us to the central mystery of today's explainer, finding the absolute biggest concentration of mass for hundreds of millions of light years. You see, we, along with all of our neighboring galaxies, are moving directly towards something incredibly massive, located about 150 to 250 million light years away. But the hurdles to spotting it are huge. Just like Andromeda 2, the region where this Great Attractor lives sits squarely behind the densest star fields and vast dust clouds of our very own galactic disk. For decades, whatever was pulling us remained entirely obscured. So how did we finally get a glimpse? Well, massive technological leaps. By deploying highly advanced X-ray telescopes, astronomers were able to pierce right through the dense dust of our galactic disk. The X-rays cut straight through all that visual noise, and when they finally got a clear look at the region where the Great Attractor was supposed to be, they detected thousands of hidden galaxies, all congregated there. It was basically a massive hidden city of stars. Section 4. The Shapley Supercluster twist. So the crucial point is, we found it, right? The thousands of hidden galaxies that were pulling us in? Well, the universe actually had a massive plot twist waiting for us. The estimated mass of the Great Attractor region was a staggering 1,000 trillion suns. That's a lot of mass. But when astronomers actually ran the math, it still wasn't enough to explain our trajectory. The Great Attractor wasn't our final destination. It was just a cosmic pit stop. Sort of the mediocre attractor, if you will. The math proved we were being pulled by something much, much bigger. Further analysis revealed a totally mind-blowing reality. Sitting way behind that initial mass, located a staggering 650 million light-years away, is something even more colossal. The Shapley Supercluster. This monster region has an estimated mass of 10,000 trillion suns. It's just densely packed with many thousands upon thousands of galaxies. To truly grasp the scale of the Shapley Supercluster's gravitational dominance, just consider this for a second. Absolutely everything within a 1 billion light-year radius is currently being pulled toward it. It is the true ultimate gravitational anchor of our massive corner of the universe. Section 5. The Dipole-Repeller Illusion. Okay, now that we found the cosmic giant pulling us forward, let's pivot for a second. What happens if we turn around and look in the exact opposite direction of the Shapley Supercluster? Well, we find the dipole repeller. This is an incredibly underdense, eerily empty region of space. And what's really wild is that everything in the vicinity seems to be actively moving away from it. It almost looks as if this dark void is physically pushing matter away. Now, what's really interesting about this idea is that the reality behind that push is actually an illusion. The void isn't actively repelling mass. Instead, all the mass around the void is being pulled toward denser regions, like the Shapley Supercluster. It's essentially cosmic runoff, just leaving the void completely empty. Though, to be perfectly fair to the scientific process, some researchers do still debate this, theorizing that a yet unknown repelling force might actually be at work in these dark regions. Section 6. The Drive to Understand. From hidden galaxies crashing into our own to invisible gravitational behemoths 650 million light-years away. Honestly, it's pretty easy to feel small. The humbling truth is that we are still in the very, very early days of understanding our cosmic place. We can observe these massive groups and staggering voids, but the universe is just an impossibly large puzzle. Our technology is still limited, and it's almost guaranteed that our current theories are going to shift and evolve as new data becomes accessible to us. Now, some people might ask, if the universe is too big to fully comprehend, and our theories will just keep changing anyway, what's the point? Well, discovering our place in the universe is simply fascinating. I am so incredibly grateful to the bright minds working on these very problems, mapping the unmappable. As the source material for this explainer so beautifully puts it, this innate sense of wonder and curiosity is what drives the evolution of mankind. That insatiable need to explore and understand everything around us, that is absolutely our greatest human trait. And that brings us to our final thought for today's explainer. Think about it. If a colossal structure like the Shapley Supercluster, containing 10,000 trillion suns, could stay hidden behind the dust of our own galaxy for most of human history, what other invisible giants might be hiding just beyond our current technological reach? The universe is out there, waiting to be discovered, and I literally cannot wait to see what we find next. Thank you so much for joining me. Keep learning, and as always, keep looking up.